And now for the last talk in the session for today, I would like to welcome Professor Qiang Yang. Qiang Yang is the new Bright Professor of Engineering and the Chair Professor at Hong Kong University of Science and Technology. He was also the founding head of Noah's Ark Lab, this is from Huawei, where he has really spent a lot of time deploying very successful data mining, machine learning applications. He's going to talk to us today about the importance of user modeling and its applications in the telecom space as well as the web space. One thing that he shared with me before this session is he was actually exposed to KDD in 1995 when it was a workshop in Montreal. He almost did not make it. He was wondering about what this KDD stuff is all about. And opened the door and attended that workshop, and here he is, really in the thick of things in KDD. So for all the young researchers and students out here, as you roam the halls of this particular conference, if something else comes up of interest to you, and you're wondering whether you should open the door or not, you have the answer. Please do open the door and explore some new areas. You never know, that might be your passion going forward. Please welcome Qiang Yang.
Thank you, Jeff. Okay, it's really a great pleasure to speak here. This is like my dream stage. So today, I'm going to share with you some of my experiences working with user modeling. And really, it's the accumulation of some experiences working with some great companies, such as Huawei, and as well as a few other startups. So let me first start up by looking at the questions I'm going to ask, and hopefully I will answer to some extent. So as far as user modeling goes, we wonder the questions like about user. Who are you? Okay, where are you? That is, what is your context? What is your current situation? And what will happen next? Will you be satisfied with my recommendation next? But before I go into the technical stuff, let me first show you this picture. Who knows what this is all about? Exams, right. So this is one of the most important exams in China for young people. It's called the national exam. And every year, about 8 million students participate in it, and that will determine their the whole lifetime of their career. And so this is very important. As a result, after the exam, when they choose what to do, they face the question. After they receive their exam scores, they will have to determine put down their preferences as to which universities they prefer to go to. They are given a few choices, and it's often a hit and miss. Okay, so for example, if I choose this university and the university doesn't choose me, then I miss out on this opportunity. I have to go down my list. And if in the end a very low ranking university choose me, then I really lose out. And so it's like dating almost. Okay, you may like the girl, but you may not be liked by the girl. Okay. So these questions are being asked. Some students are going for fame, for city, and for some potentials. And there are a variety of issues. So thus, modeling for the students' intention and modeling of the university's choices of the students become a critical issue. So this is one very live example of what user modeling is about. Okay, so in short, user modeling is trying to understand the user in terms of a huge number of data sources, including internet, voices, text, images, and structured, unstructured data, and in order to build models that reflect on, for example, people's personal information, relationships, preferences, in order to satisfy the following needs, such as making recommendations, summary of results, and so on. So there are several myths that I'm going to address in this talk. The first one is the belief that individual data is sufficient in modeling individual user, but that's not true. Okay, and here I'm going to raise the issue of collaborative crowd intelligence. And the second one I'm going to look at is one-step modeling. Is it enough? It's not enough. Okay, because it's a continual and incremental process, and it requires some techniques such as lifelong learning, transfer learning. And thirdly, people's attention have always been on model engineering, algorithms and sophisticated algorithms and so on. But my claim here is that it's the wrong focus, and our focus should be really on features. And feature engineering is what makes a huge difference. And finally, privacy. When you deal with users, privacy is always a concern, and it's not something to be taken as an afterthought. And it should be privacy-centric, the solution. Okay, so I'm going to go through each of these in this talk, hopefully addressing each one with a live example. So let's start with the first one, okay, collaborative crowd intelligence. So let's go back to that national exam and choice of university example. So the student, as we consider, this is a single user, but he's wondering a few questions that are very representative. So for example, I like model airplanes. Which major should I choose, right? You may recommend mechanical engineering or aerospace engineering. I prefer to work in big cities. Which university should I choose? That gives me the highest likelihood of doing that. Finally, I don't want to be single when I graduate. Where should I go? Okay. Now, when you face these questions, in fact, when you look at individuals' data, that's far less sufficient. What you should do, what we wish to have is something. I wonder if you have watched this movie, Mulan. Okay. In fact, it was on the United flight when I'm on my way here. So when Mulan was facing the choice of whether or not to go to the army to fight, there's a whole bunch of ancestors come say, yes, go, and others say, don't go, right? So these advisors, they are basing the decision, the recommendation on their experiences they are giving Mulan. So finally, Mulan took the right decision. So here we are trying to do the same thing, except it's probably more complicated. You are here to start with, and you want to be here. Which path should you take? And it's really a lifetime life path. But each of these paths is a decision based on many others. And these many others are people who are like you. And so this is the idea of collaborative filtering in recommender systems. And here, likewise, we can use this in terms of crowd intelligence if we have enough data. But what data? In fact, this company I'm advising on is called IPIN. It's using pieces of data that are based on mostly CVs, curriculum vitae. Okay, so it collected about 200 million of those CVs from across China, and building these little bits and pieces together in order to build a huge graph of career paths such as this, in order to make advices on where you stand and how many people are similar to you. And if you take this path, how likely you are going to land where you want to be. So this graph of career path, this huge graph, can answer quite a number of queries. So let me give you some examples on how these queries are answered. So this is like the, it's actually used in this year's national exam. So here is an example. So you will learn a lot of Chinese in the next minute. Okay. So here's a map of China where it's a display of graduates from a single school from Wuhan. And that's where all these graduates landed. And that gives you an idea, if you want to go to a city, what the probability is for you. And here is the from that school, which career people landed. As you can see, well, that the first one says electrical engineering, and electrical engineering is the highest probability. And the next one gives you a distribution of majors as well as companies. Well, the first one being Huawei. As we know, it's the biggest employer in that area. No wonder, right? And the second thing is, suppose we wonder if you want to join, if you want to advise the student to join a certain company, what's the likelihood for you to be promoted? And what is the prospect for you 3 years later, say if you want to jump to another company? And then, based on this data, you can get this information. So this sheet gives the current salary distribution, but then more importantly, in this company, what is the distribution of people who joined this company? Where were they before? So for Tencent, for example, maybe a sizable number came from Huawei, came from ZTE, and so on. And after that, where did people land? Internet companies, for example, right? And the distribution of various type of work in this company. Okay, so for example, in this June, this was applied to so all the this year's high school graduates, and for any single one, it was able to find for the last 3 years a great number of people who are like you. So this is 3,000 people who are like a particular person, and making this recommendation, they were able to accumulate, serve about 2 million registered users in just 2 weeks. Okay, because this is a very, very important decision in one's life, and usually the parents will go and register for the students and pay for the membership fee. And as a result, a lot of people come in and ask queries. And so this is one point where this company can make use of this big data and give people user modeling decisions. Another point is 4 years later, in fact, when the student graduate. Okay, so it really traces the people in a lifetime.
Do these guys actually pay $2 billion in 2 weeks?
Some of them do, but it's not as simple as just multiply, because there's a lot of discount to try to get users. Right. But this is another aspect of it, right? If you give people enough incentive, more people will upload their CVs, and therefore your data will be more accurate. So it's a loop like that. Another story I tried to tell you came from a very different company called Wechat. I happen to be an advisor for Wechat. As we know, Wechat is quite similar to WhatsApp plus Facebook in China. Okay, so it's a company that's a subsidiary of Tencent, focusing on instant messaging. So it actually started in 2010, but quickly grew into a user base with about 500 million. Okay, so there are 2 zeros missing. Okay. Small mistake. Yeah, that's correct. Okay. Now what's interesting about this company is, besides this many users, it also holds what's known as O2O service ID, which is like for banks and so on. They all set up shops on this platform for customer services, for payment, and so on. And there are a total of 8 million of them, astronomical numbers. So compared to WhatsApp is still by far the largest instant messaging, but WeChat is very quickly getting onto that. So a recent a recent statistic says that about, on average, users get on to WeChat about 10 times a day. And if you ask your Chinese colleagues around, almost everybody has WeChat, and almost everybody gets on all the time. Okay, so more than 10 times, I bet. But let me focus on the user modeling aspect. So before we start user modeling, we must have some intelligent techniques to move data from unstructured format into structured. And that calls for example, image understanding, for face recognition, object recognition, image segmentation, and so on. So there's a lot of interesting work done here, as well as deep learning in natural language and speech, understanding the syntax, machine translation, sentiment analysis, and speech. Okay, so all these tools are available in order to make user modeling possible. On the simpler side, so one particular thing is using AI to try to understand users' context. So here's one example. Suppose, so we all know that TV advertisement has been a one-way information traffic, right? You watch TV and that's it. The TV doesn't know who's watching it. But with WeChat, actually with the AI technique, if you turn on WeChat, WeChat can listen in to the music and understand which channel you are watching, and then immediately register you with the channel. So at the same time, the channel understands who you are, and you can interact with the channel and maybe even influence the next program. So this has been done in this past Chinese New Year, and almost 800 million people participated in one Chinese Spring New Year, the national festival. So this enables people to really advertisement people to understand who's watching them, and in order to determine the next advertisement in response to the viewers' population in real time, right? Another one is this interesting experiment it did with the mobile advertisement. So on WeChat, it's, as I said, it's like Facebook. It has a wall. Everybody has a wall to display their photos, their text, their sentiment. So based on this, you can understand who the user is and what status the user is based on the neighborhood of the user. Okay, so based on that, you can paint a pretty good picture of the user's current sentiment, the user's current preferences even, in order to determine the right advertisement to put on. So after this campaign, people actually loved the advertisement so much that they were seeking. They were saying, "Oh, damn! I didn't get an advertisement today." So completely changed their view. And once they get a advertisement that is belong to higher class, such as a Mercedes-Benz, they show off in their next wall picture. But this is for commercial. In fact, with 600 million people, we can do a lot of social good, and this is one example. It's called I Can Hear. Okay, so the purpose is to help the visually impaired people with audio books, with producing audio books. So the idea is first, everybody who subscribe to this service can ask for a paragraph from some books, and then they can read aloud, no matter where they are. So for example, even in my talk, if you want to, you can speak to this and contribute to a 30-second segment of the book. Then after thousands of pieces, in fact, there were 2 million pieces accumulated, speech recognition then compares all these to a standard voice to see how to rate the quality of this contribution. And then the AI software chains the best voice segments accumulated into a real audiobook and then released to the visually impaired people. So by this way, about 1.2 million people participated in the space of half a year, and about 100 books were completed and released to about 100 visually impaired schools for these people to use. Okay, so this is a process that was started in October 15th and ended in June this year. Okay, now let's go on to the next topic. As I mentioned, a second issue about user modeling is it's never a one-step process. It's a continual process, as illustrated in this picture, right? So we are like going through a maze. We are trying to find we are this rat. And we try to constantly recognize where we are. But then through learning, we learn a new model, apply it, and then get feedback, and this loop should continue. Okay, and so this is a very real abstract picture of what's going on in the real world. In the real world, we all understand that recommendation, product recommendation, is a very real scenario for user modeling, right? So a lot of competitions are set up based on this. But then this process, if you look at the feedback actually belongs to two types. The positive means the user clicked on your recommendation. But the more troublesome is the negative one. If the user doesn't click on something, it's hard to interpret because maybe the user is interested but did not click on it, or the user simply was not interested in it. Okay, so if you look at the time, for example, the days from 0 to 250, this is a real recording from a Tencent data stream on about 500 different items. You can see that the interest is a function of time. And so does this show that the recommendation engine is not working well? In fact, there's a deeper reason why there's a constant drop-off in terms of the recommendation quality. And it can be illustrated by this picture. Suppose we use a model is this straight line, right? It partitions from the positive ones, which are blue, from the negative ones, which are red. The displayed ones are in the green circle. Then over time, let's say in the next session, if this is the positive example, then your model may be biased towards the positive example. Okay, and as a result, in the next moment, because you only have a few positive examples to work with, you may be tricked into an even simpler model, which is wrong. And this is the simpler model, which is 50%. The accuracy drops greatly. Okay, so in other words, you are the victim of your success because you only receive positive examples. You don't get negative examples. The accuracy actually drops. And when accuracy drops, you get more negative examples. And that's when your performance will pick up again. So over time, the performance is this roller coaster. Okay, so that's one strong motivation for why we need a feedback process. And in fact, the mathematical model we use for solving this is a reinforcement learning model instead of a one-shot matrix-based situation model. And in this complex mathematical model, you work on a reward, which is a maximization over the returns in the horizon, in a finite or infinite horizon. And that is based on the computation of where you are, which is the state S, and the actions which you can take, the recommendation you make, and the feedback you get. Okay, so this is continuous process. If you train this over the history of the recommendation and feedback, you will get the optimal result, which is not biased as much. Now, another example I try to go back is the Wechat example, where, as I mentioned, there are 8 million service IDs, and each one corresponds to a call center. Literally, a call center, there are 8 million call centers living on the Wechat platform. And so to provide services for millions of users, one of the best ways is to design a QA robot, question answering robot. But question answering actually meets a lot of challenges. For example, there's many of them suffer from a limited range of questions, and there's a lack of deep semantic analysis. So for example, this is the question we post on Siri saying, I'm bored, and the Siri says, congratulations, now you can do what you didn't have time to do, which is not personalized. It doesn't model myself, and it's quite useless, okay? So this is the schematic of this Vivian robot, which is going to be released in Wechat very soon. And so it starts from text and speech. It does natural language understanding, including query analysis, intent analysis, and then it went into a whole bunch of data mining algorithms on the big data, including the knowledge graph, the user profile, dialogue analysis, different sessions, in order to understand the topological knowledge of the graph, understand the semantics underlying the query, the text, and recommendation. And finally, natural language generator will generate the language back to the user. So a very important aspect of this, we are talking about reinforcement learning, and the thing it learns is a knowledge graph. Okay, so over time, it tries to analyze the result of the feedback in order to grow. So understand the different semantic interpretations of a term in order to expand the query. Okay, and here, in order to have the reinforcement learning, the system is organized in a closed loop, so that the closed loop ends when the payment is made. Okay, usually in a conversation, we don't know if we finally satisfied the user or not. But if the user pulls up the credit card and pay, then we know the user must be satisfied, okay, with the recommendation. And so this is the way for this Vivian robot. So here's an example of Vivian. So here I'm posing a picture of a conference. The Chinese word in response says, "Oh, it looks so fun. I want to join as well." Another one says, "Well, right." So this one in Chinese basically engages in a conversation about booking a flight. Okay, and this one does cross-lingual conversation. So if you speak in English, it speaks back in Chinese. Just right. Okay. So there are a few interesting examples, but mostly it is geared toward satisfying. So it's acting as if it's a real person is behind the call center. Okay. Now I want to bring another point at this point, which is instead of focusing on model engineering, we should work on feature engineering. And so here I want to introduce another company called the Fourth Paradigm. So everybody here knows what Fourth Paradigm means, right? It means use data science, using data as a driving force for making decisions. So instead of working on a sample of the data with a small number of features, in the fourth paradigm, data science, we all focus on big data, okay? And so here's an example of what big data really means in terms of features. This is an example from Baidu search engine. So this is the volume of users search, and this is the user income accumulated from advertisement. As we can see, there's a big dip in 2009, and that is because of the saturation in the number of users and the services that can be provided. But subsequently, you can see a pickup. Okay, that pickup is mainly because of the technology change, and that's because before 2009, only one server was used to generate about 10,000 features, and after 2009, this is what Baidu used, about 20,000 servers generating about 100 billion features, and the increase in income is 800%. Okay, so this really demonstrates the power of feature engineering. The model literally stayed the same, logistic regression. Okay, so here we can see that the big data based really makes a fundamental difference in terms of the effectiveness of service. And so when we look at it, this is a paradigm change indeed, because before we were looking at a small number of features. Even though the model can be very sophisticated, the features are human managed and human generated. After that, the features are machine generated and are many times larger. Okay. And so as a result, there are many use cases. For example, in the banking industry, the income based on the feature engineering increased a great deal. And here, in addition, I want to bring the importance of explainable models. So for example, in generating the feature, we may use a very sophisticated engine, such as a deep learning engine, but there's no way for people to understand the billions of parameter values. And here we try to fit the same engine using a decision tree and tell a story of what this engine is all about. And people find this to be very acceptable and more willing to adopt the result of the engine. Okay, and finally, I want to mention the use cases of privacy-preserving data mining. As we understand, this is a big topic in data mining in databases. But looking from the telecommunications industry, for example, here is a research paper my colleagues in Huawei Nova's Arc Lab and I did this year in the VLDB conference. The use case is based on an experiment using China Unicom's data. And so here, suppose we have a telecom industry, and here we have a company which is working with the data, but in a handshake manner. It is important not to leak the user privacy into this data mining company, right? That is why we introduce privacy measures such as differential privacy, okay? Now, the data can be a whole spectrum of different type of data, such as tabular data, graph data, multimedia data, and so on. Now, so there's a whole bunch of data mining issues, and when we look at differential privacy, for example, this is a very important and very popular topic in data mining conferences, in database conferences. But then the real question is differential privacy, abbreviated as DP, is it practical? There's a budget associated with it. How is the budget and the performance traded off? Okay, so nobody actually looked into this until we look at this picture. So differential privacy, just with maybe a 5-second explanation, is when I give you two databases with one record difference, can you queries tell the difference? If you hide that difference, then you are said to be differentially privacy preserving. But there's an issue. When you do data mining, it really depends on which model you use. Maybe you use a decision tree model versus a deep learning model. And when you try to use a general model for the data mining logic, you have to then publish the data in a synthetic form where the data hides all the private information. So it's a transformed form of data. And then the data mining logic can work with this. But this actually brings a big problem because this synthetic data itself may be noise masked so much that the data mining logic may fail. Okay, so there are really two choices. One is whether we should put the differential privacy within the data mining module, or we should directly put it in the database part. Okay, so this corresponds to a general data mining module and a general differential privacy function, which may not be aware of which particular data mining algorithm is being used. Whereas this one is where the differential privacy knows the logic, for example, a decision tree versus deep learning. So the experiment is very surprising. So for example, with certain very large differential privacy budget, which means you run the potential of leak, a lot of user privacy, there's a low level of performance loss. But as soon as you decrease the budget to the usual level, industrial level, the loss is simply unacceptable. Okay, 30% of performance loss. So what does this tell us? This tells us that okay, so first of all, when you do the implementation, you should try some kind of hybrid architecture where the differential privacy part is aware of the data mining algorithm. And the second part, lesson we learned here is that differential privacy may not be the ideal solution for protecting privacy, given so much performance loss. Okay. So this is the lesson. Current privacy models do not address the privacy problem. All right. So in conclusion, here I make several observations on user modeling. So first of all, user modeling is necessarily a collaborative crowd intelligence type of modeling, and it's continuous. It is incremental, and feature engineering should be a focus. And the design of the architecture should simply be privacy-centric rather than an afterthought. Thank you.
We have time for two quick questions. Any questions? Yeah, there's one there. Can we get a microphone, please? Thank you.
Yes, thanks for the talk. I think I like the idea of the IPIN, that kind of national exam example. I'm just wondering, because that decision is so critical, it might change the life of the person, right? Whether IPIN is providing any insurance. So, and how, another word is that, how do you evaluate whether you are recommending the right path to the person?
Right. Okay. Insurance. I'm sure you are not being serious there, right? Now, yeah. So if you present the solution not as a must, but as a suggestion, just like any other suggestions, especially it's very similar, as I mentioned, to dating, right? When you recommend a girl or a boy, you don't say you must marry, you must meet. Otherwise, I insure. So it's the same issue. In fact, the feedback is important. And the feedback we get here is purely from data. So for example, people who are alike, where are they? What are they doing? Do they like their, what's their salary level? And so on and so forth. So this is very similar to taking a snapshot of the social society and then try to isolate different groups in order to simulate a person's growth from childhood to adulthood, right? You can't follow people through 80 years of their life, but you can take a snapshot and simulate it that way. So it's the same principle here. Thank you.
One more question? Yeah,
right. A question.
Can you wait for the mic, please? Thanks.
Thank you for the great talk. I'm curious how Viving was built. Since you mentioned it was designed for customer care through the Wechat platform, so I'm thinking assume Viving is built based on lots of data Wechat has. So I'm thinking how you merge the data, which is like the common knowledge, with the data private to the business. Since for customer care, you have to touch whatever is the private business to either privacy to the customer or privacy to the business. How you can merge these two together. Also wonder the business model, how really can empower the business on WeChat to really do the customer care, because it touch their database in the back too. Thank you.
Right. Yeah, you are very right that to be like a true call center, you need two types of knowledge. One is the general natural language understanding. Another is the specific business knowledge. As far as the specific business goes, there's a lot of rules at the moment. So all experts author a lot of rules. But at the same time, there's also, because WeChat connects people with people, there's a lot of room for exceptional handling. So for example, if the questions goes beyond the current set of rules, then some other people can come in and answer these questions, such as Baidu, Baike. They post some open questions, and people can come in and answer them, like on the Wikipedia. So there's also that mechanism to grow the questions. So it's really a continual process with a open-ended knowledge building part. Yeah. The business model, if you ask, is so WeChat, as we know, is a common platform. It opens up its services. So one model is so there are many different business models. Currently, when it opens up a call center and it truly reduces the traffic, the offline traffic, then there can be some profit sharing that can be done with the offline the banks, for example. Right. Mm-hmm.
Okay, let's thank Qiang once again.
Thank you.
So this brings us to the end of today's session. I hope you all have a good evening. We will pick up action at 1 o'clock tomorrow afternoon for session 3 of this track, and that will be in Ballroom A. Hope to see you all tomorrow. Take care.